Hello. This morning I'm going to work on a function to add a payment to a transaction that's already fully signed with SIGHASH all anyone can pay. So essentially meaning this transaction has no funding in it right now to pay for transaction fees, but everything else is already completely signed. Which means I cannot add a change output without invalidating the signatures that are already there on the inputs. And so in order to fund this transaction, I actually need to do it in two transactions. One is going to be to generate an output that is the proper amount to cover for the broadcasting of the second transaction, but in such a way that there's no change. So I'm basically going through the process of pre-sizing outputs. So I'm going to turn my do not disturb on. Okay, so we're going to create a function here called fund tx. I assume I need a context. I'm going to need a reference to my TXO store in order to get my UTXOs. I'm going to need to know the funding address. And for now, let's leave it at that. We might add some more stuff in the future. And this is just going to return an error. Oh, I need the actual transaction itself as well. All right. So let's see here. First thing I need to do, let's say size equals tx.bytes dot I'm just going to set a constant variable up here that's going to say sats per kilobyte. Okay, so the fee on this is going to equal size divided by 1,000. It's going to truncate. So I want to make sure, let's say, and I've done this so many different times in different ways over the years. B. So I want size per kilobyte. So let's do a math.ceil, I think it's called. Oops. Of float size divided by 1,000. Is that going to return me a float? Yes, it is. So let's just make this int then times. Okay. So phi here is a number of Satoshis that I need to add to this transaction. So let's do I'm not sure the best way to do this here. So I've got store.search, and I want to find This is fun, but I don't know all that stuff yet. Searches. What do I want here? Search members. Because this is an interface, that should not be a pointer. So the search functionality on the TXO store has a number of different kind of ways that you can call it for different use cases. So all the data is essentially, all the searchable data in our site is essentially just stored in a very, very simple table that has a member, which is like the pointer. So that's an out point for this purposes, and a score, which is essentially a timestamp of when this out point fits into the whole system. Now, the same collections that we use for searching out points are used for searching other things too. And depending on the context in which they're called, there's some different intricacies to how we call them. So I can do search members, which is just going to give me the member aspect. It doesn't care about the score. It doesn't care about anything else. It just gives me, these are the things that match your criteria. Really, it's a set. These are the things that are in your set. Search TXOs then takes those out points and does a bunch of other analysis and loads up all the data for those pointers as actual TXOs. Search TXNs does some different analysis to kind of group different TXOs together into what transactions they're part of. It doesn't really matter right now. All I really care about, I think we're going to go search TXOs, actually. So then this is going to be TXOs, actually, UTXOs. So my from table, it's going to have a owner key. Oh, that's not the from, that's key. Okay, so my search config, the key, so this is basically saying what of my sorted sets in Redis, or what of my, essentially what set am I searching against? And what I'm searching against is the one for this funding address. Now, there might be ways to do this outside of the funding whatever. I don't want to make things complicated right now. This is the set of UTXOs I'm pulling from. So I'm going to say limit of 25. I think that should be fine. So what I'm going to get here is an array of UTXOs. And because all I'm really trying to do here is pay for this transaction, in many, many cases, one UTXO is going to be more than enough to pay for the transaction. So actually, let me see here. Now, I'm going to hold off on that. So let's loop over the UTXOs. Okay, so, and actually, I'm going to get back to those. Okay, so I want to just remembered when I'm doing a search TXOs, excuse me, I have to give it more information about what data I needed loaded up. And that's actually making me rethink this. I'm actually not going to load the whole TXO. I'm just going to load the out points. Oops. And another thing I need to add here is filter spent. So I really only want unspent out points associated with this owner. And then let's make that a real out point. So out points here is just it's an array of strings. So I'm going to say out point equals lib.new out point from string. And can this return an error? Yes, it can. So if I have an error, actually right now, go back and just put my panic code. If somehow I got an out point from a database and it can't be parsed as an out point, I've got a major problem. I need to look into that. Okay, so now if I'm going to, so this is a process that is going to be called asynchronously, many times, potentially at the exact same time. So as soon as I'm working with an out point, as soon as I've identified this is a UTXO, I'm going to spend in this transaction, I need to have a mechanism to lock that, such that if any other transaction is coming in at the same moment in time, the same instance, that before I can't have two processes both trying to lock the same UTXO, or if I do, one of them needs to succeed, one of them needs to fail. So first thing I need to do here is just find out if this UTXO is already currently locked in some other transaction or for some other transaction. And how I'm going to do that is I'm going to attempt to lock it. So I have a Redis database here. So let's say else unspent unlock. Let's see here. So I'm going to try and lock something. I want a variable, and it's going to return me a Boolean if it gets locked or not. I want the Boolean to say if I was successful in locking this thing. So I guess I'm going to call it locked. And let's see. So this is my Redis database that I'm going to use to do it. And I'm going to do a set nx. And so what am I trying to do here? I need to set, so let's say keys. Okay, that works. So I'm just basically creating a field name, or actually this isn't a key, this is a, oh yeah, it is. I don't love that. So essentially I'm trying to just set a value. Yeah, no, this is absolutely right. This is what I want. I'm going to set a value in Redis. It's going to expire after a minute. And I'm doing a set nx, meaning I'll only set it if it isn't already set. So if I try to set it and that value is already set, or that key is already set, this locked is going to come back false, and nothing will have saved. So essentially, what do we got here? The key. So I'm going to go lock key out point. Actually, I want the string, so I'm going to go OP. the value that I set in the database doesn't actually matter. I'm really just trying to make it a point to say this out point I've got reserved. How long it's reserved for is going to be set by the TTL in the database, which is the next next parameter I'm going to pass in. So essentially, either this record exists or it doesn't exist. So right now, I think just for auditability's sake, go time.now.unix. Let's write a Unix timestamp in there. And the time to live is going to be time.minute. So essentially, if one process locks this UTXO, it breaks down for some reason, something else happens, it doesn't succeed, this UTXO is going to, this lock is going to expire. Currently, it's set at 1 minute. Did I not have this in, what is up here? Undefined lock key. Lock key. Did I do something weird? Oh, it wasn't saved. Is that IDX? Oh, I put in the wrong keys. That explains that. This is where I want it. There we go. Okay, so if this UTXO is locked, I'm going to say if not locked, continue. So basically, I've got 25 from the database. I'm grabbing the first one. I'm checking, is it locked? Or I'm trying to lock it. If it's already locked or I can't lock it, I'm skipping over this one, grabbing the next UTXO. And I mean, these processes are going to come, like there might be 4 or 5 that happen at the same time. So it might have to crawl over 4 or 5 of these checking. But at most times, there's not going to be more than one of these in flight. And so one lock happens, grabs that UTXO, it sticks on a transaction, broadcasts that UTXO is spent, and a new change UTXO is there. So it's like these processes are going to go really quite fast. And the locking and unlocking is just kind of a system for when it happens to be concurrent. Okay, so now that I've got an out point identified that isn't locked, let's say, so I want to go store.loadTXO. I think, okay, so I can tell, that's fine. Don't want any tags because I don't need any tags. All right, so this is just going to then load up that TXO. So the assumption on this, is that a good assumption? Let me think about this here. So I've got my transaction. I've got my TXO. I'm going to say tx dot add input oh shoot, I don't have the keys in this. This might not be where I want to do this process. Really should think these things through before I start my streaming, but it's also kind of the point to just, hey, let my process get voiced. So this functionality is actually for a client project. I'm not at liberty to show code that is in the client project, but there is some scope around this that needs client information. So I'm actually, let's see here. I'm going to remove this funding address. And what we're going to actually pass in here, and I might refactor this off stream, but I think what we're going to pass in here instead is a so we're going to pass in a private key instead. So then let's say address new address from public key. Okay. So now I've actually got the private key, which is what I'm going to need to sign these transactions anyways. Go back and forth frequently about whether I nest my ifs in this fashion, which I really, really prefer in most cases. But when I have to then put the entire payload of my function on another layer indented, or even several more layers indented, I kind of, oh shoot, if this is going to be generic, then oh no, I think does store have a network? No, it doesn't. For now, I'm just going to say this is mainnet, so that becomes a true. Oh boy. I've got the TXO loaded. Got the address. So actually, I'm going to actually pre-build a couple more things that I'm going to reuse other places. So we're going to have a locking script. And this is going to be a pay to public key oops. Pay to PKH dot lock. That takes address. I'm going back. So there's a problem with this whole approach that I was starting here, which is, so a transaction itself, it's got its outpoints, which show you, or its outputs, I should say, which show you how many Satoshis are being allocated to each one of the outputs. And on the inputs, it has pointers to outputs of previous transactions. So those previous transaction outputs contain the brain, come on, work, contain the number of Satoshis that were in those outputs, but those are not part of this transaction itself. So I don't actually know how many Satoshis are coming into this transaction. without doing a bunch of lookups. And that might be exactly what I have to do. But yeah, I mean, that's essentially it. I can't just fund this transaction without knowing what all the inputs are. Now, luckily, I have a process to do just that on kind of through my ingestion stuff. So that all takes an ingestion context. Is this getting too complicated? Okay, I have to have an ingestion context in order to do this. Now, in the code that I'm going to be calling this from, I actually do already have an index context, but let me think about this. I think I'm just going to mock this. So for this call right now, I am going to mock up an ingest context or friends. You know what? That has my transaction. That has my store on it. What if we just pass it in like that? Okay, that's going to change things up a little bit. Okay, we still got. So let's do this. Let's say sats in. Let's see, uint 64. So let's do this one. I think I can do. Can I do both on one line like that? I think I can. All right. So let's go for spend equals spends sat in equals spend. Sounds good. Oh, that should be fine. Say must. So you can run an index context in such a way that it doesn't even bother to figure out what the inputs actually are. So that is the Satoshi's variable is actually a pointer to uint64. So there are ways that you can go through and process this and not ever populate those values with the TXOs. That should not, and that will never happen here. So I don't want to be adding a nil pointer to an int, a uint, so that will break things. So this check is just making sure that it is indeed populated. Okay. So now I know how many sats in and out there are. So we're going to say my fee here, which I had down here. And apparently I deleted the size. Okay. Length of okay, so my fee is actually going to be I need to figure out, you know what? I think for easy calculations, I'm actually going to make these an int, not a u. No, I'm not. Never mind. Forget that part. Okay, so if my Satoshi's in is greater than my Satoshi's out and my fee, I'm done. In other words, if there's already enough payment added to this transaction, it has more Satoshis. In fact, that should be greater than or equal to. So let's say I have 100 Satoshis coming in and I've allocated 95 Satoshis coming out. And the fee for this transaction is going to be 1 Satoshi. Well, in that case, my sats in of 100 is greater than or equal to my sats out, which is 95, plus my fee, which is 1. So in other words, this transaction is already funded. There's not a thing we need to do about it. So we're just going to return. It's all good. So then we need to go about and figure out this stuff here. Okay. So now I've found my out point. I've locked it to make sure if it's already locked or I wasn't able to lock it, I go to the next one. Then I go to and I load up the transaction output. I add it to my transaction. I think I want to do this. Oh, I don't. Oh. Let's do this first of all. TX equals IDX CTX.TX. Okay, so I've located this out point right here. Or the I've got its output number. So to add a UTXO, I need TXID, which is the outpoint dot TXID hash. So the TXID here is actually using a chain hash object, which is, I mean, it's really just a byte array of a hash, but it's got methods to convert it to a little endian hex, or to convert it kind of between the different ways that you'll deal with vout is my out point dot vout. Locking script, that's going to be what I built out here. So this is basically all of the scripts here are just pay to public key hashes associated with this address. So that's what I'm going to do. We're going to say a locking script. Satoshis is txo.satoshis. Oh, that's a pointer. And then I need, when building transactions in the new Go SDK, there is this unlocking script template. And I think we need to build this up here somewhere. So the different templates defined in the Go SDK here, and the TypeScript SDK as well, have methods that will give you back a lock script and an unlocker, which an unlocker is basically an object, an interface that has an unlock that will do all your signatures and everything. So this takes in priv, and I can leave the sig hash flags empty for this one. So I'm just going to say nil there. Okay. So now I should be able to go. Ooh. Unlocking script template is unlocked. Okay. So basically, I've taken my transaction. I measured how big it is. That's this first part. Figure out how many Satoshis I need to add for a fee, in order to cover the fee, I should say. Well, actually, I haven't figured out yet how many I need to add. I've just figured out, do I have enough? Okay, so then get the address, get the locking script for that address, I get the unlocking script for the associated private key, I get my out points, or a set of out points to use to pay for the transaction, loop over those, I attempt to lock one. If I can lock it, all right, I'm going to add it to my input. So at this point, our sats in is increased by the amount of Satoshis in that transaction. So I'm also, let's see here. I'm going to sign this transaction. I added that input. Can I sign just one input? Probably. I mean, I know I can do it manually. Well, let's just do it manually. Actually, now I'm curious. We're going to go to the Go SDK code for a second. Let's go to transaction. This TX input. Okay, there's two of them. There's transaction input, source, read from. Okay, that doesn't have any mechanisms to sign a single input. Does this add input count? No. But I can certainly go and do this manually. So what I'm doing here, there's a transaction sign method. Let's see how this works. Check fee computed. Okay, that's fine. That's not going to blow up for anything. Okay, so let's go back to the sign. So it loops over all the inputs. If any of the inputs have an unlocking script template, then it's going to sign those. Oh, okay. So yeah, let's go back here again. I can literally just say tx.sign. What does that take and return? That returns an error. Okay. So I've gone through here. I've added a new UTXO to my input and I signed it. So now I'm actually going to copy this code over again. So by adding that input and signing that transaction, I have changed the size of the transaction. So it's possible that the... Oh, wait a second. I totally missed a step here. Okay. This is a really worthless live stream because So I forgot. What I'm actually trying to do here is create two different transactions. One transaction, which is this first one, I need to add a pre-sized payment to this transaction. Okay, that's talking through, although it's really not helpful for anyone else following. It might be helping me get my head around what I'm actually trying to do here. Okay, we're going to back up here. I've got this. So we're going to totally change this up. So my size is going to be the size of the existing transaction plus, I'm just going to hard code a value here. Let's go back over to the Go SDK. Let's go to P2PKH. Oops. Okay. The size of, oh, that's an output. No, that's not. That's the size of an input. So when I sign a P2PKH transaction, or when I add a P2PKH input and transaction, that number's not right either. A P2PKH is, on the output side, it's 34 bytes. It's always 34 bytes. We're not adding an output, though. That doesn't matter. We're adding an input. So an input is 32 bytes for a transaction ID, 4 bytes for an output pointer. Then there is the script, and the script itself is the length of a signature, which is, I'll have to look that up, but I believe it's like 67 bytes. No, it's like 73 bytes or something like that. And a pub key. Actually, let me go back to where guys was. I think that's exactly what this number is. So this 106, you know what? Maybe they did a better job of defining their logic in the TypeScript one. Oops, let's make this bigger. Let's go to their P2PKH. Yeah, there we go. So the input script size is a pub key, which ends up being 34 bytes, 33 for the pub key and 1 for the push that you use to push on the stack. Signature is 1 plus 73. They come to 108. So while I'm at it, let me make that right. Okay. So basically, we are adding to this transaction an input, which is 108 bytes plus, so that's just for the unlocking script. And then for the actual, let's go over to wiki.bitcoinsv.io. I think that's, yep. I use this site a lot. So if I go to transactions, let's actually do it here. Okay. So format of a transaction output. We have outputs. Okay, so here's an input right here. So an input is going to be 32 bytes plus 4 bytes, so that's 36. We have the in-script length, which is going to be 108 bytes, which is going to be represented by 1 byte of a var. So we're just adding one more here. So that's 37 plus 108 plus 4. So 37 plus 108 plus 4. 149. So we're adding 149 bytes to the size of this transaction. Well, actually, let's not do that yet. So first of all, I'm just making sure if I already have enough to cover what it was before I add anything, I'm returning, I'm all good. Now we're going to go size plus equals 149. I don't need to do a plus equals. I even need to add that. So let's say input needed or sats needed. Let's do that. Sats needed equals actually, I am going to do this. Size plus equals 149. Fee is going to be the exact same thing it was before. Sats needed is sats in minus, no. I'm going to, okay, sorry. My sats in are greater than my fee. So at this point, my sats out and my fee are bigger than my sats in. So what am I trying to do here? So sats needed equals sats out get my types kind of unified here a little bit. All right. So I've got a new fee here, sats needed. So however many sats I have coming out of this transaction, plus however many Satoshis I need to add as a fee for this transaction, minus how many Satoshis there are coming in is how many sats I actually need. Getting a bunch of bing bongs here. Okay. So I think I just realized I'm missing a meeting right now. That's fun. Give me just a second. I'm going to actually stop sharing my screen for just a second. I'll be right back. Yep, there's that meeting I'm supposed to be in right now. All right, well, I'm going to come back to this later. This was kind of a mess anyways, but hopefully it'll be clear when we come back. I can figure out how to close this. Bye-bye for now.